Well, hey, my fancy mathematicians. Here we go. Day 2 of working on the assessments website. So we're going to continue writing equations today. No solving. Yay! Let's take a look at question 1 and get started. We are going to do a little bit of review before we start. So I kept everything in there from yesterday. Systems of equations, two or more equations involving the same variables. Why do we do it? Helps us find unknowns. How? We could do that by substitution, elimination, graphing, and all that jazz, but we don't have to solve today. We're continuing to write. One thing to add to our list today of prior knowledge is linear equations. So we know a linear equation can be written as y equals mx plus b, where x has an exponent equal to 1, and it has a constant rate of change. So it's going to be necessary that you include that in your work today. So your CFS for today is the sentence is translated into a mathematical equation, and the explanation references both the exponent of the x as well as the ROC, whether it's constant or if it's not constant. So let's go over and take a look at question 1. So question 1. Write the following statement as a mathematical expression. So once again, you're just translating these mathematical expressions into equations, and there is no solving. You do not have to solve. So keep that in mind. There's no solving. You're just translating. All right, so let's take a look. They have let x be a number. So we talked about this yesterday where you have to define your variable, and they defined it for us. That's why it's not in your CFS for today. They defined it for us. Let x be a number. And the equation reads a number decreased by 3 squared. So a number, we're going to have that x in there, and we're decreasing it by 3 squared. So think back in your brain, to decrease something, what operation would that be? And it's going to be subtraction. And then it says decrease by 3 squared. So 3 squared would be 3 to the exponent of 2. So when you write these equations, we're going to start with y equals, and then we're going to fill in whatever the sentence read. So y equals a number decreased by 3 squared is what we are going to translate. So we're going to translate that. Decreased, I know that there's a subtraction. What are we subtracting? We're subtracting x minus 3 squared. And with this program, you're going to have to type your exponents as it states right here. So it would be y equals x minus 3 with a little caret 2. That's how you would type it, and it'll register it as correct. Then you get down to part B. Is the expression linear or nonlinear? And so go back to our prior knowledge. We know a linear equation has to be y equals mx plus b. The x has an exponent of 1, and there's a constant rate of change. And if we look here, we see that our x has an exponent of 1, so we're good to go. This square up here is there to trick you, right? It's not on the x, it's on the constant, so it's okay, because we could evaluate 3 squared as being 9. And so this equation is linear because the x has an exponent of 1, making it have a constant rate of change. And that's what you would type for your explanation in part C. Easy peasy lemon squeezy. So that was for question 1. So if you're watching this video, you're all set up. And then I have a little treat for you, for those of you who are watching. We're going to walk through another example together. I'm not telling you which number it is. You will have to take notes, and hopefully it comes up when you are doing your practice assignment. But here is what you would type in. You would just type in y equals x minus 3 caret 2. That's all you're typing. They gave us the let statement, so we don't have to write that. Your answer would just be y equals 3 minus, y equals x minus 3 caret 2. All right, so let's take a look at the other problem. It's our other problem right here. We'll hit play. Oops, sorry about my messages coming up. All right. So the next question, mystery question. So take notes so you have it. Write the following statement. Once again, we are not solving, we're just translating. And they give us the let x be a number. There's your given. It says the sum of twice a number and 4 times a number subtracted from the number squared. Oy, oy, oy. It's a lot in there. But we're going to break it up and translate it carefully. Our equation is going to be written as y equals, but we have to break this down. So what I'm doing here is I'm separating it because I know that there's a sum that's grouped together, and I know that there's a number squared, and we're subtracting it. And the way that it's typed, you have to be really careful. It reads the sum subtracted from. So that statement subtracted from tells me to flip-flop it. So you see how I drew the arrow? That means that this expression right here comes first, then that. So we have the number squared coming first, subtract it, or take away the sum. So I start with my y equals. I start with the x squared, a number squared. Ooh, already I'm like, is this going to be linear? I don't think so. But we'll hold off on part B and C in a second. And so it's going to be x squared minus, and all of this stuff in here. So this reads twice a number, so 2x, and 4 times a number, and we're adding those two things. So 2x plus the sum, so it tells us to add 4x. And so then if you were to answer the question, is this linear? It is not, because it has the 2 on the x. And if you were going to type it, you would type it with the caret over here, as you see in the video. And our answer to that would be it's not linear because your x has an exponent. And you'll see me answering it right here. So is this expression linear? We know a linear equation is y equals mx plus b. And when we compare that to the equation we got from the problem before, y equals x squared minus the sum of 2x plus 4x, that right away should tell you that because of the x squared, it's not going to be linear, because for an equation to be linear, the exponent on the x has to be equal to 1, giving it a constant rate of change. And so because this x has an exponent of 2 not equal to 1, this doesn't have a constant rate of change. So make sure you hit that CFS where you're referencing the exponent on the x as well as the rate of change. And this obviously is super messy. Your answers will be complete and a lot more formal than what I'm jotting down here. So it says because x has an exponent greater than 1, this is not linear, and it's not a constant rate of change. All right, so to recap what's going on today, so you are continuing to translate those sentences into mathematical equations. You are answering the question if it's linear or nonlinear, and in your explanation, you are referencing the exponent on the x, and if it's going to have a constant rate of change or not a constant rate of change. You have the answers to 2 of the questions. The first question, then the other one's a mystery question. So I hope you took notes, and I hope you have a wonderful day growing that math brain of yours. Call me, text me, beat me if you want to reach me, and let me know if you have any bugs or anything like that. Hope you guys have a great day. Bye. If I can figure out how to unrecord this. All right.